Hello, guys. Welcome to the second episode of AI Unchained podcast. I'm Chi, the co-founder and CEO of KITE AI. Together with me are my always dear co-founder and CTO Scott, and also the guest today is Zhenzhong. We call him Z usually, who is yeah, we're super honored and happy to have an insightful conversation today.
Awesome. Great to be here. Good to see you both as well.
Perfect. So a little bit again, the context about Kai. We're building a purpose-built layer one for AI that is focusing on the identity and attribution for the trust of the future agentic AI. And Z today is again the guest who is currently an engineering leader at Meta. Z has spent his career at the intersection of data and AI for over like 15 years already, even longer, I believe, building things that actually scale and matter. A little bit context and background about what exactly he was built before. Before he joined Meta, he co-founded a startup called KITE to bridge machine learning with real-time data, which got acquired by Voltron Data. Then he served as a VP of engineering there. And before that, he built Netflix real-time data infrastructure from the ground up, powering thousands of internet use cases and crunching trillions of events every day. He's also helped scale Microsoft Azure's early data center management systems and worked on MSN and Bing Video way back when it's going head to head with YouTube. So these days, Z is dive into how unstructured data and foundation models can change the way we search, discover, and make decisions. He's also super passionate about leading teams, coaching people, and helping others grow, as much as he's about shipping great product. And when he's not building the future of data and AI, he's enjoy racing motorcycle, which is very, very cool sport, by the way. But be careful. And chasing that perfect balance of risk taking and pushing the boundary. So welcome, Z, to
Thank
today's
you for
episode.
having me.
Yeah. Awesome. Z, did I miss anything about your background, or is there anything you want to share a little bit more?
That's pretty good. I think that's pretty much my entire background. I would say, uh, I'm a engineer. Like by default, right? So I started my career with lots of kind of distributed system, knowledges, and kind of gradually getting into the real time data, and then later, evolved into the machine learning space, and more recently, Gen AI space. Kind of really curious about that space as well. I would say one thing I really proud of myself is really dig deep into the engineering aspect, right? Kind of figuring out details about distributed system, for example, that leads you down to, things like relativity, physics, things like that, right? And, the machine learning part is also interesting because just a few years ago, since we're kind of segregating and going towards like different directions, right? And there's a lot of opportunities on kind of bring things together, consolidating, bringing technologies and people together for doing some of those things, interesting things. We can dive into a lot of those interesting topics, down the line as well. Yeah.
So actually, just a follow on this topic, one of the interesting thing I want to ask your opinion is that what do you think is the biggest difference between machine learning before Gen AI and Gen AI or machine after Gen AI, and what's the difference?
I think it completely changed everything, right? Before Gen AI, it's more about kind of doing structured data, using training data set, right? That's more structured as table, right? So pretty much the entire world of technology was developed towards that, right? Data lake, transactional databases, data storage, even real-time data, event-driven architecture, things like that. But after Gen AI, everything kind of just got disrupted, right? So structured data, audio, video, which we had some technology in that space, but it wasn't really kind of the data infrastructures and some of the DevOps infrastructure, AI, ops infrastructure wasn't really kind of built towards that. So all of a sudden, everything kind of there's opportunity, right? At the same time, the Gen AI, more recently, the agentic workflow is becoming like super mainstream, right? So that also kind of brings new challenges in the space as well. For example, governance, trust, right? How do you balance, productivity and reliability at the same time? Because it's essentially two sides of the same coin. You cannot balance, you cannot optimize both without having, to kind of invest into the underlying infrastructure, right? So things like that. If you have like any specific area we should dive into, I'm happy to. Yeah.
Yeah, so I think from my perspective, one of the biggest thing leading to Gen AI is that, for example, whichever machine learning project you built before, I'm pretty sure you need like a data engineer to massage data scientist to build the model, and then you need a machine learning engineer and software engineer to deploy the model and just make a productionized. So it probably costs anywhere between 1 million to 10 million to deploy a very small classifier, for example, yes or no classifier. I feel like with the Gen AI, you can just build on top of foundational model, and then the foundational model is smart enough. You just need to build prompt engineering and make it work. I think that's my major difference. And then sometimes I say, hey, if the foundational model is not smart enough, forget about it. Just wait for it to become smart enough. Otherwise, it's probably still the same traditional machine learning building process.
Yeah, I agree with that part. I think a lot of things become so much simpler, right? The vibe coding trend recently, that means, anyone can potentially develop your own websites, software stack, right? So that definitely, we rely more and more on foundational models. But there's also a lot of similarity, right? Between the traditional model and, the large language model, foundational model in this case. For example, it still needs to kind of go through the entire machine learning pipeline, like as you mentioned, right? The data engineering aspect of things, getting we don't work on features anymore, but still getting on training data sets, getting things ready still requires a lot of effort in that space, right? After that, when you have the initial model, you still do a lot of offline evaluation, golden data tests, right? Trend test split, those sort of situation in the offline evaluation world, right? And then when you're ready, you still move, that into the online evaluation space, do your A/B tests, right? You see that on OpenAI as well, right? Sometimes you give a prompt, it give you like two different answers, right? So that's, they potentially underneath who are using different models for giving you back different responses and have you to rate, the response there, right? So that's the traditional DevOps A/B, test applying to the more modern side of things, right? And then after that, you still apply monitoring, observability technique, around either the traditional machine learning space or the large language model space, right? And then finally, you move into the inferencing space where things are more online, right? But the major difference there is, there's a major shift into, from using CPU into GPU space. There's also a lot of trend, kind of changing in the hardware space in that regard as well.
So I definitely agree here. Yeah.
Yeah, Scott, you want to finish your thoughts? Question?
I think actually the AI completely transform how the data infrastructure would work. If you think about traditional data infrastructure, I call it traditional data infrastructure.
Yes.
You have this indexing part, transactional database. You have analytical database. You have your CDC streaming database. But I feel like with the new Gen AI, I think maybe in a few years, everything fetching the data, do analytic may be done by your agent. In this case, it should be completely hide away. Probably should be completely hide away from the user. In this case, we may not have like this business analyst or data analyst in next few years. All things should be done by agent, and the underlying agent can use the tool. Like it should be just as simple as data tool. Whether it come from streaming DB, come from transactional DB, analytical DB, really don't matter. As long as you give me the data at lowest cost, that's actually great. I think definitely Gen AI transform tons of infrastructure. Like we used to has this debate of Postgres versus MySQL, transactional DB versus analytical DB, streaming DB, all this kind of thing. I think it's become obsolete in this case. It should be just all the complexity should be ahead of it. I think in this case.
Yeah. I think you're touching a really interesting point. If we look back from history, right, any important technology all goes through this, initially everything's super complicated. You need to kind of put pieces of different technologies together, in order for it to work, right? But eventually, if it goes mainstream, one of the interesting observation is, it will become invisible. What I mean by that is, there's huge amount of abstractions going to build on top. So, for everyday users, you really need to know like what's working underneath the hood, right? So one example of that is, electricity, right? 100, 200 years ago, it's super complicated process, right? So we even, use different standards like the hertz, the voltages, everyone, there's probably different company has different standards there. But eventually, if you look at today, it's as simple as, plugging your electronic devices in, right? You probably don't need to understand like what's running behind the scene. Is that atomic power? Is that something else, right? So I think Gen AI is probably going through similar, things in that space as well, right? That includes all the data infrastructures, machine learning, life cycle stages, feature engineering stages, for the traditional machine learning space as well, right? So similar things gonna happen. Everything's gonna become a lot simpler, for end users to use.
So Z, actually, since you guys are touching more like at the infrastructure, and I like the point. One of the things that you mentioned about one of the key differences, like you see, is actually transition from this CPU to GPU stage, and that's also reminded the previous company that you were at, like the company that acquired Claypot, Virtual Data. They're actually also like not only on the modeling side, but even for the data query engine, they're
Yeah.
trying to make it a GPU accelerated query engine experience to people. I'm curious about how, just like from the practical perspective, how that
Yep.
went, and do you think that's is even like a like a trend? It's a trend that everything
Yeah.
is GPU accelerated.
I can let me talk a little bit more about the context on like what we worked on before on the streaming data space, right? And then why GPU makes sense for doing some of the interesting work in that space, and then we can expand after that, right? So I started working on real-time data in Netflix around 2015, right? So we built the entire infrastructure from ground up and eventually, scaled over 2,000 use cases within the company, right? So we operating at extraordinary scale, and we were super proud of that. Actually, we were one of the first team in the industry hitting that 1 trillion, events per day sort of scale. Super proud of that. But underneath the hood, if you look at the entire infrastructure, right? So it's running on a lot of distributed instances on the cloud, right? So that was a traditional pattern of architecture, from 2015 probably up to 2023, 2024, things like that, right? So that's a way of doing stuff, right? Making sure things are horizontally scalable and you can grow from 1 million events to 1 trillion events, just kind of by hitting that button, right? So that's the design pattern we, use to kind of guide our designs. But the problem is for streaming data, it's very complex, right? So we're talking about there's many techniques around, how to dispatch data into different services, how to keep checkpoints, how to, keep consistencies, right? As I mentioned earlier, at the end of this technology investment, it's physics, right? So when data are traveling at light speed, you can potentially have different frame of views, and and that's going to make consistency extremely hard in distributed system, right? So that's just the nature of things, when you divide and conquer, right? Another analogy here is, if you have a complex problem, you want to delegate to 10,000 people versus having a simple problem, having one person to do it. It's the former is probably going to be so much harder, right? So many overheads and complexity to getting things right. So that was the situation we were facing, right? Because of this complexity, we have to invest a lot into the underlying technologies, reliabilities, consistencies, all that kind of stuff, which was critical, for many companies, right? That's also the reason why, streaming, especially like real-time machine learning, it's extremely hard for you to go mainstream because it's so hard to get it right? So company typically have to, invest into a team on doing the operation, and people have to wake up in the middle of the night, to do some of the on-call operations. People resonate, right? So I see some nods there. So what changed is, when GPU started happening, right? Especially larger and larger GPU capacity, right? That's one aspect. The other, unnoticed aspect people typically kind of ignore is the network aspect, right? So imagine 10 years ago, what's your typical home network? What's your workspace network? We're probably talking about 1 gigabits per second network at the maximum 10 years ago, right? So today, if you look at data center, we're seeing, each individual network card has 400 gigabits per second, right? If you bridge them together,
it's more than that, actually.
It's more than that, you can aggregate them together to get 800 gigabits per second, right? So terabits per second is not far away, from technology point of view, right? But how is that going to change things, right? So as I mentioned earlier, I was alluding to it, right? So if you can put all the information, on a single instance and do it in a single batch and do it in a less distributed way, things become so much easier, right? You can imagine that. So since also becomes so much efficient and less causing reliability issues, all the kind of stuff, all of that is great, for since kind of getting into the real-time space, right? But that requires underlying kind of foundational change from shifting from CPU processing to GPU processing, right? And why GPU specifically, right? So I was alluding to network. A lot of people don't think about this, but when we think about processing huge, tons of data on single instance, if we, especially in the terabytes range, and sometimes maybe getting to tens of terabytes or even petabytes range, right? Moving data in and out of the instance becomes a bottleneck, right? Even when we're operating at 800 gigabits per second, right? But the real bottleneck is actually CPU, right? So imagine you need to move, a terabyte of data, in a single second, in and out of this network, which is typical for large language model trainings, situations like data crunchings, all that kind of stuff, right? If you do the math into understanding how CPU cycles work and how to process network packets, right? How to parse, the network packet into different, pieces. And some of those will actually involve like kernel times and all that, which is very technical oriented. But if you do the math there, a terabyte of data typically involves, probably 30 something CPU cores processing at the full speed, which means, leaving you no CPU, if you have a server, right? Typically, 30 something cores, if you have a crazy server, that might have like hundreds cores and stuff, right? But the point here is, if you only processing data, right, using CPUs, you're leaving no processing power for doing anything else, right? So that's where GPU can comes in, where, you can GPU for doing CPU offloading, right? You can put GPUs on the network card, crazy things like that, so while you reading the network data in, you can start, using GPUs to parsing data stuff, right? So a lot of those things, as I mentioned earlier, is a complexity underneath the hood, right? No, as a user, you probably don't see a lot of those, but there's so many innovations happens in these spaces.
From my perspective, I think one of the trend since Gen AI, particularly since AlexNet on 2012, is that as I come from a distributed system background. In distributed system, AI, data infrastructure, and blockchain actually all belong to distributed system. It's like under different assumptions.
Right.
I think all the previous distributed system is that we want to have a built system, a complex system on the cheapest machine. That's the assumption. We want to have cheapest, most economic, make sense machine. That's actually bring by the Google, the big table, the Google file system. In this case, it's all measured by cost and efficiency. So in this case, you buy the most cost-effective CPU, and then you buy very cheap disk, and then you run a distributed system, the whole distributed system on top of these commodity machines. But I think what actually NVIDIA AlexNet brings is that instead of say, hey, economic doesn't make sense if you just do this, horizontal skill. Mm-hmm. It actually makes sense. You have very powerful, in parallel running this GPU, running all this simple stateless job calculation. It's actually cheaper that way in this case, particularly for AI, AI training, inference is much cheaper that way. I think at the end of the day, it's really about cost and efficiency. And then it becomes cheaper that way, like I always say, and the Jensen from NVIDIA always say, the more you buy, the more you save. That's actually true. That's actually true, because comparing to skill out solution for AI-related job, the more you buy, the more you save in this case. So that's why, there is a crazy, like NVIDIA GTC conference last month. They have this crazy NVLinks. They charge for $3,000 just to connect 2 GPU. $3,000 a cable connect to GPU. If you want to have like all the cable cover the whole rack of the GPU, it's going to cost you 300K just for the cable connect GPU. But per unit level, it still makes sense. The reason is that I think the cable is actually transferred 800 terabytes data per second. In this case, you use some optical way to transfer the data. So that's why if you calculate the number of data cost, per terabytes of data per money, it still makes sense. It's still like the more you buy, the more you save. So this is actually a fundamental, I think this is a fundamental assumption change in this case. So that's why it's very different than traditional distributed system like even like 5 years ago.
Yeah, there is definitely a trend on moving from that cheap distributed, like cloud-based horizontal scaling into more vertical scaling, right? So there's a trend for HPC like, hardware to become more popular, right? So I wouldn't be surprised, there's going to be more of those instances, available in the cloud ecosystem, in your own data centers and things like that. So that trend is there, and GPU is going to be like a major part of it for sure. Yeah.
Yeah, so actually, when you said about some of the scales, then reminded me some of the comparison, now especially for crypto folks, like if we look at how much even our high throughput chains in the space, like Solana is processing, it's still nothing compared to some of the Web2 internet companies scale. For example, like Solana, theoretically, we're talking about it has about 700,000 or like even 800,000 TPS. And even like at this like a theoretical maximum level, then if you times that to like a 24 and 60 and 60, that's still like like 0.06 trillion events per day, something. But even like the real the practical number is more like a 4,000 per second. So yeah, I think we still have a like large space
Yeah.
to grow
So
to
I
grow
think,
the
what's interesting
business.
for me is the on-chain data versus off-chain data, which kind of brings a lot of opportunity, right? So one thing I've kind of been thinking a lot about is, for the crypto, right? You don't store your personal data on crypto chains, right? So there's opportunity for bringing your personal data from, I even kind of started my own home lab, right? So kind of keep storing, terabytes and, tens of terabytes. My goal is to get into petabytes, let's see, if we can get to that, right? But the point here is, you're going to maintain a lot of your private personal data in your own space, right? Whether it's your home lab or, your cloud systems. But there's going to be a lot of interesting things you can do on bringing, the crypto chain and personal data together to enable that sort of kind of, AI for everyone sort of situation, right? So which is probably, things that's overlooked in the entire industry right now, right? So everyone's kind of focused on enterprise productivities, using agents for driving a lot of that. But there's also a lot of opportunity for, agents to drive your personal things going down the line, right? So I know you guys are working a lot on that, so we'd love to kind of hear more thoughts on that.
Yeah, actually, since you are talking about now the privacy side, I'm also curious about from your view. Like maybe we can, like share from different word how things are moving, and also like maybe start from Z. I would love to start from your side. Honestly speaking, that's also one of the very early questions I want to ask before we dive into now a lot of like those technical conversations.
Right.
Why Meta, right? Like a Meta in some way it's an enterprise company that now you the AI side that the AI team that you are leading from my knowledge it's actually coming from a lot of like the enterprise angle. But meanwhile, of course, like Llama and yesterday LlamaCon, the whole focus was open source. Like like it's still they're trying to push for the open source of the word. But anyways, at least from your observation in the enterprise side, like why do you join Meta and what you're exactly doing there? Yeah.
Yep. That's a very interesting question. So after the company got acquired by Voltron Data, right? So we went through a stage of kind of looking at opportunities and things like that. So I was looking at the entire AI plus machine learning plus data space, and just kind of breaking down on every single component and see where the investments are, where some of the opportunities are, right? So given the back force is Gen AI presumably is going to change the world, how people work, right? So agents, workflow, productivity, and all that kind of stuff. I was looking more from a different angle on what are some of the infrastructure, more engineering complexity where we need to invest into to help envision this world, right? Because not everything happens in the Gen AI, foundational model space, right? Plus, I'm not an expert in that space. I would love to be able to help, on pushing the world forward, but maybe, from my own kind of purview, right? So I was looking at all these different spaces and noticed one undervalued and underperceived space, which is the governance space, right? So why? Let me kind of tell you a little bit more about my thinking in this space, right? Assuming, the productivity in the enterprise is going to change a lot, right? Down the line, there's going to be more agents that, as Scott mentioned earlier, can, help with doing some of even the development work, doing the code reviews, doing tests, right? So there's a lot of interesting innovation in that space already. So conceptually, let's imagine, the changes happens in the enterprise space, right? So, engineers or agents, they make changes to the code base, right? So whether it's model or code or config, whatever, they essentially, checking those changes into the GitHub repository. And today there is a series of, DevOps, machine learning ops, large language model ops procedures are moving, those changes step by step into production, right? So increasing production productivity means, the bandwidth, the volume of changes is going to increase dramatically, right? So a simple example here is, if you are able to make one commit, previously, today with vibe coding, all the AI help, you probably can ship, 10 commits, even hundreds, right? Depends on your productivity there. What's the implication of that? We have to think deeper, right? The implication of that is, assuming we have the same ratio, the probability of bad things going to production, that's going to cause issues, right? So, imagine the productivity volume of changes goes tenfold, hundredfold, even with the same probability of bad things potentially getting to, production, for whatever reason, right? It could be manual reason, it could be overlooked, it could be, bug in the system, things like that. That's going to be, very drastically bad for enterprises, right? So that means, you probably, as on cost, you won't get to sleep, right? As, production system, you won't actually have full online time, for any company, that's bad, right? So these are the foundational investment we should start thinking about, right? So what are some of the governance principles, right? That we should start applying to the entire ecosystem. I do see a lot of this as foundational for, agents to go mainstream, right? Even before you can reach this, everyday, individual users, AI for everyone. I think the future is there, but it's going to take a little bit of time, right? The other thing worth mentioning here is the governance topic itself is not new, right? So in the past few years, we talked a lot about data governance, right? So privacies, right? Lineages, making sure, governing rules are applied on the data, so you don't ship bad stuff into production, like private information, right? So we see a trend in that space where, the governance is shifting from data governance into a few different dimensions. Capacity being one, reliability being one, right? Efficiency being another one, a lot of those things, right? So each individual, I think, is going to gain a lot of tractions to ensure, maybe let me kind of expand into a little bit more, right? So I talked a lot about reliability and why invest into governing principles, to bring that probability of bad things going to production lower the possible, right? So that's one space. The capacity space, as we discussed earlier, right? So a lot of shift is going to happen, between the CPU and GPU, shifting from, smaller instances into large instances. So there's also the capacity side of governance, to help, ensuring that changes moving to production with the right capacity, right? There's also the, efficiency side of things, how do we ensure, workloads are more efficient goes into production first. So there's also, governing policies needs to be kind of happening there. So there's a lot of things, happens in the enterprise space. So I was looking around in this space and quite fascinating, right? This is a foundation to get, to participate, to contribute into the large language model, Gen AI space, from my background, distributed system, data, and machine learning space, right? So that was quite exciting to me. And Meta was doing some of this work right here in the space. So I was excited to kind of join Meta to contribute my effort in that space.
Yeah, I actually want to add a few more points here. I think governance is beyond enterprise in this case. one thing we noticed that it happened on Twitter yesterday. There is a Solana trader actually use OpenAI to recommend it, trade something, and then OpenAI recommended him a rug pull project, and then he end up with sending $3,000 to the project. The reason is that Solana, the OpenAI actually fetch data. In this case, it fetch data poisoned data. In this case, so that's why the model is trained. In this case, it's actually poisoned, and then it gives them like a rug pull project, and then that's why it causes a direct loss for this trader. I think currently, if you look at today, most of the foundation model is updated anywhere between 3 months to 6 months. You have every 6 months you have a new foundational model, or every 3 months you publish a new foundational model. This time will become shorter and shorter. I think in the future we may have like a new foundational model every hour. Maybe combined with continuous learning or active learning in this progress. It's become more and more important. You actually can govern your data into just govern data. Make sure you filter all the potential attack data poisons in this data poisoning in this case, and that's why I think governance will become more and more important beyond enterprise. It's also important for consumer as well in this case. I would imagine 10 years, 15 years, everyone will have its own foundational model, customized foundational model, which active learning in this case, and it's become more and more important in this case. So that's why I think governance is beyond enterprise.
I agree. I think definitely there's a lot more space we haven't kind of exploring into, right? So imagine you have your personal agents. Some of the agent maybe buy tickets for you. Some of the agent organize information for you. Maybe take recordings and translate that into text. Things like that, right? So when agents can work with each other, that's where governance needs to have a lot of applications, right? So security, how do you put guardianship around agents? How do we kind of ensure humans stay in the loop for approval processes, right? Ensuring productivity, but at the same time, ensuring bad things don't happen, right? So that's also the reason why governance and enablement are exactly two sides of the same coin, right? So typically when we invest into governance, we also want to enable agents and workflows, right? Human beings, can work together on some of those kind of principles, right? But we're kind of getting into, the conceptual kind of philosophical space here.
Yeah. So Z, actually, but that's a very interesting concept. Actually, since we were talking about what your thoughts and especially regarding to what you are doing right now at Meta, and you touched the agent parts. This is where I'm, quite curious about what is the new type of like a governance needs and the practice are surfacing from the agentic AI besides what's the traditional or like the mainstream type of governance that we used to talk about, for example, coming from the data side or even like a model guardrail, especially when it comes to data, like traditional machine learning or, even like the analytics type of use cases, like what Databricks or Snowflake were doing. For example, when I was at Databricks, there's a lot of work regarding, like you talked about, the data lineage, the metadata catalog type of searching and keep an eye on, and also like the access control and all the stuff. That is very well designed around data, maybe more on the structured data. There's a lot of new demands coming from the unstructured data, but it's mainly like on the data side. And then last year or year before, a lot of things in the like a guardrail space or governance space is more regarding like the model governance and model guardrail. But now, especially this year, we're coming into the agentic AI world, and like tons of agentic flows coming out, and a lot of agents are designed for both enterprises, productivity use cases, and also like daily use cases for people in the future, like help you to do commerce and all the stuff. I'm curious from the governance angle if you see anything that's is a kind of like new or like a kind of different than before what we had. Yeah, when it comes to AI governance.
Yeah, I think governance, as I briefly mentioned earlier, right? So if we look at just the past few years, it was more focused on the data aspect of things, right? So as you mentioned, lineage, having visibility into how data flow, ownership information, and putting PII privacy guardrails on some of the data pipelines. That was the main focus for a lot of company, right? And the main driver behind that is simple, right? So there's laws, right? European laws and privacy laws, ensuring company that can satisfy the rules. So it's a reaction to the governing rules, like broader social governing rules, right? That implements things in the enterprise, right? So that's why it's less, important from a personal AI point of view, on some of those things, right? But what's changing here is, the back force that's changing is agents is becoming more and more popular, right? So we can imagine a space where agents participate in, code changes, right? Being, doing code reviews, right? And sometimes, I've also seen a lot of agent companies that actually help human being to, increase productivity, for example, by scraping websites, right? Monitoring, certain changes on the websites and sending notifications and being part of the workflow, right? So, it's very similar in this case where, agents are using natural languages to interact with humans and also possibly with other agents, down the line as well, right? So that's the back force that's different from the data requirements, right? So what's happening in this case is the trust, right? So essentially, how does enterprises and every single human being trusting your counterparts, agents, to perform the work you need to do, right? So a lot of that kind of goes into having a visibility of what's happening, right? So same principles apply to data, right? And understanding what are some of the policies we want to kind of define for the agents, right? So the agents kind of stick to the rules, right? So while we're not fully there yet, right? So we start with simple things like governing policies, right? Simple things as for this agent to make this commit to go into production, you set up a multiple checkpoints to ensure this agent or collaboration, a bunch of agents collaborating with each other, are satisfying the rules you set, right? For example, making sure the data quality is high, right? So for example, making sure when you ship machine learning model changes into production, whether it's traditional or large language model, you ensure enough tests is being done, right? So that's where in the tech space, where a lot of agents being used on helping achieving productivity, you need to look over their shoulder, right? So also the other thing here is when agents are in operation, do you need some human guardian, right? For overseeing all the actions, being responsible, having the audit trails, right? So things like that. I think a lot of this kind of comes down to agent is new, right? So while we're still establishing that trust, which technology eventually is going to mature to the point everything is fully trusted, right? But we are going through that stage right now, so we need to build enough foundation on building that trust.
So I'm very glad that actually you're talking about AJ is new, and it's just getting started to building the trust, because actually Scott and I can share more on like what we are thinking recently, especially about what we want to do is to really build the trust foundation, or like the trust framework for agentic AI to work with, basically the agentic AI network that to work with each other. Because what you are talking about, for example, at Meta, when it comes to like a multiple agent work together, you need to set up checkpoints and be able to make sure the operations going, or like the data operations going to agents, or like with the right information, all this stuff. That's is still in some way come up with a foundational assumption that those agents right now are built by the Meta employees, or like Meta engineers, and it's more like for internal, like there's already in some way there's already some trust to come out of box when the agent is built and coming from the parties that we know, or like we trust,
Right.
Which is like the trust that we pick back on the human side, on the developer side. But imagine a future where actually we talked also about like how in the future there's going to be more like a like trillions of agents that's running in the world for billions of peoples right now to do work for them, not just for the company production work or like the enterprise related work, but also for your personal work. In that case, a lot of the agents come in to collaborate with each other actually you don't even know like where the agents come from, or like by default you don't have like that kind of
Right.
like a trust assumption that's piggybacked from the institution like Meta or like Uber or like other places, then how can we still be able to collaborate with each other? Is actually something that's is going to be a real challenge and the real needs coming
Yeah.
from the internet, the future internet that is dominated by agents.
Yeah. So I remember, Microsoft CEO just a few months ago, he mentioned, the aging, agentic workflow, aging investment is gonna replace the existing SaaS, infrastructures, in a way that's similar to what you're describing here, right? So, essentially, all the software vendors is gonna become agent vendors, right? So when they sell, their solutions, so when agent needs, first of all, agent needs to be able to collaborate with each other, but also agents needs to work in enterprise situations or personal AI situation, right? So in this case, that trust is something that every single company needs to kind of overcome, right? Not just for enterprises, but also for personal, individuals. If individuals want to kind of start using AIs, for the personal information there as well, right? So it is something we have to kind of overcome, right? Building more trust layers, right? So there's also going to be a lot of technology innovation in this space, right? So looking at the foundational model agent space, a lot of things are changing, right? Technologies, how agents are deployed, how agents potentially can build agents themselves, things like that. But they also, things that is constant, that's not going to change, which is governing laws, right? So we need governing laws, like policies defined, right? So it will be different individual by individuals, right? Enterprises from enterprises, but there's probably going to be a common consensus on what are the common things that we need to apply to agents, right? For example, in the human world, you don't kill people. That's one law, right? So there's probably going to be similar laws, that we need to come up with, right? Writing as policies, maybe even policy as code stored alongside with agents, right? So that's how we can start kind of defining some of these policies on governing the behaviors, right? And ultimately, at the end of the day, transparency and visibility is also going to be another thing, right? But yeah, nobody knows the answer at this point, I would say. But I think we're going through that stage. A lot of innovation is going to happen. Oh, I think you
Scott,
muted.
I think you're muted.
I think trust here is actually referring to two things here. First is that you trust your agent. In this case, that's actually something different than agent trusts another agent. In this case, for example, your personal agent or your local agent want to interact with the rest of the service agent. In this case, you're going to need you need to have some reputation score. You need to have some reason why you trust this service agent. It could be like the service agent provide you with something at stake. If a service agent go wrong, then you actually get compensated for it. And then additionally, I think if you build a channel of trust, if the service agent rely on another service agent, rely on another service agent, you need to have a channel of trust chains. In this case, the things become more and more complex. In this case, most important thing, I think now the existing infrastructure support trustful agent. That's actually what we built for, trustful agent, because if the agent will do most of the work for you, you're going to have agent do very tiny things, fetch data, we paid 1 cent, do some additional work, I pay you less than 1 cent in this case. You're not going to have human in the loop just to dispute that very small work. Human probably going to just say, hey, I approve you to do this work. I authorize you $20 to do the work. Underlying, you need to have a chance, you channel the service agent do the work, and then you need to delegate the trust to channel the service agent. So that's why the only way I think it work is that you have something at stake. If the agent go wrong, you got compensated for it. I think that's the only solution work in this case. So that's what KITE AI is building for, ID and trust for service agent in this case, to guarantee all this agent, don't trust, just verify. And in this case, if something went wrong, you get compensated for it.
Awesome. Definitely looking forward to your guys' product. Trust but verify. That's actually a very common thing. That it's a good principle. Yes.
Yeah, actually, since Sky is kind of categorizing trust into two different trusts. This also reminded me yesterday because I was at the PayPal Dev Day, which they are more focused on the agentic commerce topics. And I really like how they phrase, like their CTO was phrasing how agentic commerce is completely built on top of trust, or trust is absolutely like the top prerequisite for agents to be able to use for commerce. But in that scenario, in some way, it's still more coming from like the first scenario what we talked about. The trust is coming from, do you believe as a user that when you use the agent, agent will do something correctly on your behalf? For example, like when I'm asking this agent to order, uh, to purchase hiking shoes for me, is that like purchase the right brand with the right purpose, because I need that to be warm, not like like a too cool, and I need that to be like under like $200 budget, something like that. So that is more like right now I think the governance and kind of like a trust guardrail rules that a lot of the companies are trying to apply to agent when they are building for like agentic commerce scenarios. Which again, like I think PayPal has done a great job. For example, like they have their toolkits coming out of like built on top of their API that's wrapped up into MCP server, so that developers can really just call the MCPs to integrate their core API capabilities to create like order, manage order, and shipping at like creating shipping labels and all this stuff, and make payments and so on and so forth. But on the other side, like what as Scott mentioned, the second scenario is where it will become more interesting, which is become like the chain of like operations from agent to other agents and other like service provider, become a network of thing. And in this network, the even like more critical and challenging part was, this is not just all the trusted known entity to the trusted known entity, right? Because if this agent is, let's say, provided by Meta for your user, because Meta also was doing, there's a lot of like the good product and networks like on Instagram, for example. And if you want your Instagram, you're like looking around of some of the KOL on Instagram about some of the product, and now you are trying to purchase that product from a certain like a website or e-commerce, and then let's say it's from like Instagram to Amazon, for example. And in this case, you can have like agents that serve on Instagram to help you to order something, talk to like Amazon. In this case, it's like a noun-to-noun type of entity. And that is where a lot of like the trust already kind of baked in the process, because it's non-entity that piggyback to the trust from institution side or from the enterprise. However, in the future, again, it's more become like autonomous agent complex network. There's a lot of like the parties involved in the process might not come from like those institution backed type of entity. In that case, how do you address like the chain of trust, and like if something goes wrong, who is responsible for? I think that's become like more kind of like a challenging and interesting process we need to handle.
Yeah, I have some thoughts. Want to kind of get into a little bit more kind of philosophical debate here, right? So
Yeah.
I think, since we're talking about trust, let's first understand what trust is, right? By looking at human behaviors, how human interact with each other, and how do we actually build that trust? There's different levels of trust, right? The highest level of trust is, the identity-based trust. Means, we share the same identity. I trust you by default, right? But aging is definitely not in that category, because, it doesn't share the same human identity just yet, right? So the question is, how do we move through the different stages of trust and eventually kind of get to, that level of trust between human beings and, agents, right? So we have a long way to go before that. But let's look at, what are the different levels of trust, right? So for human beings, the basic level of trust is contractual, right? Put things down on paper and we agree with each other. We both will mutually respect that contract. And the laws, there will be governing laws, legal laws, that protect us from, keeping our words, right? So that's a basic level of trust where I do feel, the on-chain, chain of trust, right? That kind of gives you that visibility and guaranteed, via the existing rules, right? So that's a basic level of trust. What we need to kind of first get to, right? that's how we going there, setting up a governing rules, other kind of stuff based on that principle of trust. Right. What's the next level of trust? The next level I would say will be task-based trust. Right. So that means we work together. Right. And after a period of time, I have observed how you work. How you produce results, how we communicate, how do we interact. And a lot of this is kind of built based on I can predict your behavior, based on my observation of you, past observation, right? So that predictability, becomes my trust in you on being able to handle the task correctly, right? So how this applies to the agent space is, initially when we either as individuals or enterprises don't trust a single agent just yet, what should we do? Just kind of put it into production, maybe give 1% of the traffic to see how it behaves, right? Measure the results, right? Gradually, understanding the behavior. That's why you need to kind of have some guardrails and gatings for agent workflows, right? You don't immediately want to kind of open the floodgate, for things, right? So that's the second level of trust, where you gradually earn that respect over time, right? Relation-based trust, I think, this is the most probably the hardest, to kind of explain, because of human behaviors, we all have emotions, we stay with each other, for a long time, and then, we build that level of kind of relational based trust, right? That's why we reach out, to catch up with people, right? Keep a good relationship with people. I think, aging eventually will probably also need to kind of get into that. We talk on the emotional level, but I think that's very far away from the current reality of the technology, right? And then, the last bit will be identity. That will be the hardest to achieve. But we'll see, how the world evolves.
But
Yeah.
the most valuable layer, if we can achieve,
Yes.
because I do
So-
think agents also need identity. Yeah.
One thing I want to mention is that let's actually separate emotional trust with transactional, the trust in transactional stuff. In this case, I think for trust is that it's also based on based on the skill. For example, we have legal laws, we have contracts in this case, and then I think that's probably protects the skill from anywhere between $1,000 to $10 million or maybe $100 million in this case. So in this case, it's actually guarantee if you break the contract transactionally, you get you pay for it. You probably punish for it in this case. But I think in the agentic world, most of this is going to be a very, very small scale. If for example, you provide me some data, but the data is actually not accurate in this case. There is an error in the data. So agentic should be your agent, agentic AI should be spot this, and then it probably shouldn't be $1,000, but it could be like a $1 because I pay you less 0.1 cents, something like that. I need to punish you for certain things, compensate for my loss. So that's why I think the ID and trust. First is that ID and trust are hand to hand. You cannot trust without ID. You cannot. ID is for trust. The goal is for trust, but you need to have ID for trust. Second is that you require a completely agentic AI infrastructure support this in this case, because I can hardly imagine for every single service and data for agentic AI, you actually have a legal contract for it. In this case, that's actually hard. So that's why the smart contract fits this really well, because it can measure at a very small scale. You can even pay and punish at 0.1 cents. But in this case, you can cover very small scale, very granularity. I think that's actually what we're working with too. Yeah.
Yeah, I think that's very, very exciting, right? Because the technology unlocks those potential for us, right? Back in the days when we're talking about physical contracts, right? So it just doesn't make any sense to go through the legal systems, all the core system to full $1,000 contract, right? You probably will let it go. The cost you pay for lawyers is probably exceed that, right? But in today's world, technology unblocks some of those situations where we can get more granular, right? So everyone can get that level of kind of protection there as well. So that's the first level of trust. I would definitely get in there for sure. Yeah.
Yeah, this actually is. I really like how the last point you mentioned is one of the key reasons why, and also that's related to. I remember Bessemer's Ventures article that they end of last year talked about agentic commerce. Why this is like a new thing, or why this is more exciting than like a new new revolution compared to the 10 years ago, like an online e-commerce type of a scenario, and also compared to like the physical commerce. Every single revolution is to make the liquidity, make the granular to the like more granular level. You can purchase quicker. You can, when it comes to from physical commerce to online commerce, you can access the goods anywhere from the world globally, and you can purchase again with a more, instead of like you have to do like more like a wholesale type of purchase, like a big bag. You can purchase the one. And now with agents, you can even like do very, very granular, very fractional stuff in real time. And that's require like this infrastructure on the line, from like a real-time streaming data infrastructure to like a real-time inference model to, like the like Scott mentioned, identity to enable like this smart contract or smart service level agreement at that granular level, and also even for payments transaction, that's all need to support this granular and real-time level thing. So that's why it's from an infrastructure perspective, everything needs to be kind of like upgraded to support this agentic native workflow and transactions between each other. Yeah.
Yep.
But yeah, so super exciting. We're only but 2 minutes away from the end of the session, and I also saw Edward, who is one of the listeners, ask interesting questions that would love to Z collect your thoughts on. So they mentioned that when designing AI system for real world scale, what trade-off do you most often encounter between performance accuracy and ethical responsibly, and how do you prioritize them, especially given that what you are doing right now, Amanda? Yeah.
Got it. So what are the three different dimensions? Ethics.
Two, between the performance accuracy and ethical responsibility, and how do you prioritize them?
I think they're very tightly close together, especially, this is not relating to my work, right? Just kind of personal view on this. I believe they're very tightly kind of integrated together because, when we're building systems, right, in the traditional world, everything's a little bit more kind of predictable, right? So there's no, large language model hallucination back in the days when we were working with, machine learning models and data engineering, all that kind of stuff, right? But these days, with the introduction of large language model, especially, when trained large language model can generate hallucinated data, that's where a lot of the biases can come in, right? So it is important, for the users to get more accurate data, for the reason why, information kind of flows, and the fake information will actually cause more harm than good, right? So I think it is important to kind of gradually stepping up the game on improving the accuracy. That will actually kind of help a lot with ethics concerns, biases, all that kind of stuff, right? So performance, the real thing here is, there's going to be a lot of innovations in the underlying kind of infrastructure space, right? So shifting from CPU to GPU being one, right? There's also going to be other innovation happens in that space. So I'm not too worried about that. Eventually, as technology always does, it's going to figure out a way to kind of improve performance, accuracies, right? But as human beings, our role here for working with agents, large language model, foundational model, is sticking up with our principle, sticking with principles, right? What worked, for human work is having common consensus on legal laws, right? Having a shared, set of a culture, but also enable diversity, all that kind of stuff, right? So how do we enable that work when working with agents? It's important. I don't know if that answers questions. It's a little bit kind of abstract and, philosophical, but I hope it does. Happy to follow up, if there's a follow-up question there.
Amazing. Yeah, actually for your audience, like I know that actually another audience just ask a follow-up question. So what you're saying, so seems like people are quite interested in this topic, which by the way, I do think it's very important because like we talked about, there's like AI for enterprises and there's also AI for everyone. Especially I think for a lot of audiences today, they probably come from more like the AI for everyone, that how, like they can, how AI will help them, but meanwhile potentially going to be, like cost potential troubles or challenges about the as a everyone as a human being in the world. So I think that's why the audience are quite interested in this topic. And if you guys have any follow-up questions, we also have these accent handler that's been added into the post. Feel free to actually ask him questions as well about this topic. But yeah, I think this is a very important topics among especially the KITE community, given that our mission is more trying to build AI for everybody.
Yeah. So if we look at the word, right, the common consensus back in the days, before all the introduction of large language model and all that, is investing into the area where it's going to generate revenue, which is enterprise related typically, right? So, but given that large language model, foundational model, Gen AI is starting, so some of this kind of common consensus might change down the line, right? So it doesn't mean, what we worked in the past is going to work in the future. So this is where we actually redefine some of the future, right? So how do we, start introducing technologies that brings more value to everybody, like right now? So really appreciate, the work you guys are doing, all the innovations you guys are taking, and the new value, the bucket, new bucket of value you guys are creating here, right? So this path is gonna be a little bit uncertain, all right? But it's the nature of doing startup, I think, it's gonna resonate here. We all know doing a startup is, both taking a lot of pain, but really enjoy the pain out of it, right? So this is part of that exercise. You guys are doing great work for unleashing the power of Gen AI to everybody, right? So that's going to be very, very exciting.
Amazing. Thank you so much. I really appreciate Azi, your faith on us. And your insights about what how AI is evolved and what people are focusing on from the other side of the world right now, especially like you said, a lot of the work that you guys are doing at Meta. And also like the previous company, I believe that Voltron Data and Claypots is sort of like all coming from more like the enterprise and like more like the the other side of the practice and focus. Yeah, so
For sure.
it's amazing. Yeah.
Glad to be here.
Awesome. So any last questions that Scott you have for Z, or Z, any last comments and insights you want to share before we end up the podcast?
I think I'm good. All I wanted to say is I'm really looking forward to AI for everybody's kind of outcome, right? So even personally, I'm invested into doing that. I tend to collect my own data and using AI to generate value for me personally. So looking forward to how KITE AI is going to play a bigger role in the space. Maybe eventually I want to kind of build something on top of it too. So looking forward to that day. Yeah.
That would be amazing. Awesome. Thank you so much. And thank you, Z. Thank you, Scott. Thank you, everybody who spends time with us today. And really hope you enjoy the conversations and the discussion. Yeah.
Thank you. See you guys
Awesome.
later.
Thank you.
Bye.
Have a good day. Bye-bye.